We have one more example of solving a quadratic equation by factoring. We ended last video talking about how part A and B of this example were considered easy, quote, easy trinomials. And now in part C, we have a hard trinomial because now my A does not equal 1. So when I have something in front of that squared variable, this time it's an m squared, when I have some coefficient in front of that squared variable, it is a hard trinomial. So let's see how this changes my problem here. So still the same 4 steps though. First, make sure the equation is in standard form, and it is because it equals 0. It doesn't matter what side the 0 is on, it does equal 0. Next, GCF, and I don't have any this time because I can't divide 5, 7, and 2 by anything. So we're already to step 3 of factoring. So we will go into our X. My A times C is 5 times 2 to give me 10. My B term is the 7. So what two numbers, when I add them together, add up to 7, but when I multiply, they multiply to 10. Pause the video if you want a little bit more time to think about that. And you can list those out if you need to. But that is going to be 2 and 5. And let's go 5 and 2. It doesn't matter. Okay. Now, before, when I had easy trinomials, we would say it factored to these two numbers here. So we would say this would factor to m plus 5 times m plus 2. I cannot say that for this one because right off the bat, when I use my FOIL method, which is first, outer, inner, last, my first terms right here are m and m. And m times m gives me m squared, but I need this to multiply to a 5m squared. So I cannot just say it factors to m plus 5 and m plus 2. So what we have to do is rewrite the middle term. So I'm going to start this way over here just so I have more room to write. So I have 0 equals 5m squared plus 5m plus 2m. I'm going to squeeze in here a plus 2. Hey, so where did I come up with that? I brought down my first term, my 5m squared. I brought down my last term, my 2. But this 5 or this 7m right here got rewrote using these two numbers here to now become 5m plus 2m. I have not changed my problem at all. If I combine my like terms here, 5m plus 2m gets me back up to 7m. So I haven't changed my problem. I've just, for lack of better terms, unsimplified it. I have taken those 3 terms, I've expanded out that middle term. So now I have 1, 2, 3, 4 different terms. When you have 4 terms, you can factor by grouping. So you'll group your first 2 up together. And what is your GCF of your first 2 terms? And that's a 5m. So I'm going to pull out a 5m and then divide. 5m squared divided by 5m is m. 5m divided by 5m is 1. Okay, if I distribute back, I get to this right here. 5m times m is 5m squared. 5m times 1 is 5m. So now I'm going to look at my second group. What is the GCF out of 2m plus 2? And that is 2. So 2m divided by 2 is m, and 2 divided by 2 is 1. Again, if I distribute back, 2m give me 2m, and 2 and 1 give me 2. So if you notice, we have the same thing here in both of these binomials. So that's your first binomial. We will have m plus 1. Your second binomial comes from the GCFs. So that's going to leave you with a 5m plus 2. And now we have factored. So now we can use the 0 factor property. And we'll have m plus 1 equals 0. So we'll subtract that 1 over and get m equals -1. So there is one solution. And then we have 5m plus 2 equals 0. Subtract your 2 over to get 5m equals negative 2. And then divide by 5 to get m equals negative 2 over 5. Now you can check these the same way we did last time, where you plug in a -1 to both of these m's and see, do you get 0? And then you can plug in -2 over 5 to both of these m's, and again, do you get 0? But continue on to the next video, and I'm going to show you how to check this in your calculator using the graph, and then how you could have just found the x-intercept using your calculator using the graph.